All right, let's look at the distances between points and planes. All right, so let's say you have a point outside of the plane and you have a plane. And we like to know the distance between the plane and the point, right? So what we want to do is this. Let's say you have a point on the plane. Let's call it Q, right? Then we're going to form a vector from Q to P. So Q to P, right? Then the distance is going to be a projection onto the normal direction, normal vector of the plane. So it's going to look kind of like this. So you project it into the normal direction, right? So you have a perpendicular here, right? Then angle here is going to be, so let's say, let's use a different color. Oops. Let's say angle here is going to be theta there, right? So if you know the distance between Q and P, so let's just say find the distance. This is going to be oops. I want a different color. So distance between, so vector QP, right? Then what you want to do is this is just going to be we can use a trig ratio. So the magnitude of vector QP times cosine. So this one right here, the length or distance that we're looking for is going to be magnitude of vector QP. Then you have times the cosine of the angle theta, right? Then what we can do is we can actually do this because we have a similar expression if you take the dot product. So think of taking a dot product QP with the actually I'm gonna go down here vector QP with the normal vector n, right? And remember that this is going to have a value of QP, magnitude of QP times magnitude of n times cosine of theta, right? So only thing that's extra is this guy. So we can easily get rid of that by dividing it through by magnitude of normal vector. So this is going to be QP, and then divide by magnitude of vector n, and this is going to give us magnitude of QP times cosine of theta, right? So if you want to find the distance, what we want to do is, so therefore, since cosine could give you a negative value, so we want to avoid that. So the distance is going to be just the absolute value of QP dot product with the normal vector. Then you would want to divide by that, right? Absolute value, the normal of n. Right. Another way to write that would be just the absolute value of dot product between QP with the unit normal vector. So it's a normal vector with the length u. So we can say where u is simply take the normal vector and rescale it so that the length is equal to 1, right? So that's that. So that's how you find the distance between point and a plane. Right. So let's look at a concrete example here. Right. So point P is 3, 1, a negative 1, 2, and the equation of the plane is 5x minus y minus z equals 4. Right. So first we have to find Q. Right. So Q could be any point on that plane. So I'm going to do this. All right, so I don't know what it is. So to make our lives easier, what if I put x equals 0, y equals 0? All right. So in order to satisfy this equation of the plane, I put x equals 0, y equals 0. You can put different numbers, but I like zeros. So negative z has to be equal to 4. So z has to be negative 4. All right. So 0, 0, negative 4 satisfy the equation of the plane, which means that this point is on that plane. All right. So we found Q. All right. So then we can find the vector QP. All right. So that's going to be 3 minus 0 is 3. Negative minus 0 is negative 1. 2 minus negative 4, so it's going to be 6. All right. So you have QP, right? And from there, we can, the equation of the plane, we have a normal vector, which would be 5, comma, negative 1, comma, negative 1. All right? Then the unit normal vector would be, so you just have to divide through by its length. So it's the same thing, 5, negative 1, comma, negative 1. But we would have to divide by square root of 5 squared plus negative 1 squared plus negative 1 squared. So which is going to be 5 comma negative 1 comma negative 1 over square root of 25 plus 1, so it's a 27. Right? So we have that. All right, then let's try to find the distance d. So distance d is going to be absolute value of QP dot product with the unit normal vector u. All right, so this is going to be QP is 3 comma negative 1 comma 6 dot product with 5 comma negative 1 comma negative 1, and then you just have to divide through by square root of 27. All right, so this is going to be equal to, all right, so 3 times 5 is 15, and it has to be absolute value, it could be negative, and negative 1 times negative 1 is 1, and 6 times negative 1 would be negative 6, and over square root of 27, and here, and that's going to be let's see, that's going to be 10 over and square root of 27, so it's square root of 27, which is a 3 square root of 3. All right, so I mean, if you want to I guess you can multiply top and bottom by square root of 3, square root of 3. That way you can get 9 on the bottom, then you have a 10 square root of 3. All right, so that's the distance between the point and the given plane. All right, that's it. I hope that this was clear.